We're ready to go. Hello, good morning, good afternoon, good evening from wherever you are. The people here are looking spry after last night's festivities. Well, maybe not so spry, a little less spry. Today, I'm here to talk about the performance of writing data. And I more want you to think about not just the performance. The performance we can talk about buffer pools, and we can talk about a lot of things like that. But it's understanding the nature of the types of writing you're doing to understand what you need to worry about. Because people said, oh, is RAID 5 okay now? Because we have SSD and we have all of those IOPS. And the answer is kind of. It's okay, except when you absolutely are going to need it. And when are you absolutely going to need it? On a failure. And that means you're going to have to go back and you're going to have to restore your entire database. And doing that doesn't matter how much cache you have. It does matter how many IOPS you get, but you're still going to overflow the cache. You're still going to go out there and you're going to be at a much slower speed than you want to be. So we'll think about things that don't happen all the time. White Star Software, you've seen enough of our presentations to know who we are. If you don't know who we are, go to our website. But what I want to talk about is, why is write performance so important? It's so important. Batiste did a beautiful presentation yesterday about how costly it is to archive, to purge data. And he showed us how much resources were used in that case scenario. So it's important because there are operations that you're going to do that you are very, very hard pressed to find a better way of doing. So it makes it more difficult. You have to have offline options. You have to do all those things on those big types of bulk operations. We'll talk about the hardware setup. I talked about this during the read portion of it, and the same rules basically apply. What we want to do is we want to make sure that we're set up to do the best writes that we possibly can. And that means that we're not only supporting writes, but we're supporting all the reads that are on the system, which we know are way more abundant. The reason writes are important is because they're much more costly. Deletes are more costly because there's lots more stuff to do in the database manager. There's lots more stuff to do on disk. There's lots more stuff to do all the way across that. And because of the more operations that you're doing, because of the number of operations you're doing, anything that you do inefficiently gets magnified quite a bit. So what we want to do is we want to make sure that we do the right things at the right times of the day. We'll talk about database internals about a little bit. We'll talk some human engineering. And I talked about human engineering yesterday, where I was talking about moving things from peak periods of the day and moving them to off periods of the day. This really holds true for write operations, because does it matter if an EDI transaction gets put in 1 second after it comes in, or could it be put in 10 minutes after it, and I could bulk up more of them? So there might be something intelligent that we can do in the bulking of transactions to make it more efficient. And then we'll talk about some application advice and then a little bit of wrap up. You have databases to store data. So if you can't get data in, you're not going to be able to read it out. Operations are less frequent but much more expensive. And people think about updates, they think about humans updating things in the database. And in reality, nowadays, that's a very small portion of the updates that databases do. Databases are getting real-time feeds. Databases are getting stuff from other applications. So there's a lot of information that's coming across to the database and being put in there that is beyond what humans do. And we tend to focus on the humans because they complain. These batch processes don't complain. But the problem is that the humans that are complaining are probably running fairly efficient code, but they might be competing with very inefficient code. So we want to make sure that we know who's doing the updates and what they're doing. So like I said, we have human data entry, we have EDI or online orders, then we have bulk things that we do, like purges of data, that we don't do that frequently, but the costs are so high that we want to make sure that we do everything we possibly can. And like Paul said yesterday, we don't want you to use -I or -R to try to make it fast unless it's an all or nothing type of operation. But we do want you to look at it intelligently and do the right thing. So we want to bulk these up in groups because we know that a group of deletes is going to be more efficient than a singular delete. And that's because you're going to have a transaction start node, a transaction end node, all of that if you keep doing that very, very tight transactions instead of bulking a few together. So one of the things that no one ever thinks of as a write activity is backup and recovery. They think about the recovery aspect of it, but they say, I've never recovered my database, or I haven't recovered it in 10 years. Well, one, that's probably not true, and two, the second, you think that you're going to have to do it tomorrow. The backup portion actually does loads of writes as well, because everyone I know backs up to disk. So I'm backing up from one disk, and I'm likely backing it up and storing it on the same exact disk array that I'm backing up from. So what I'm doing is I'm just pushing that into that cache for the disk subsystem I'm using, either a SAN or hopefully that you have local storage, and you're still going to be using up that cache, and that's going to be taking cache away from other people. So it's important to understand that when you do this backup process, that you don't have it conflict with other large processes out there. And I had a client, and they had this really strange problem, and every Thursday their application got slow. And they had moved everything completely off that application. So the only thing that they needed to run, they could run by itself. So they ran it in complete isolation. And if they ran it on Tuesday, it would work fine. If they ran it on Thursday, it worked horribly. It turns out that they were sharing a disk array with PeopleSoft, and PeopleSoft was running payroll on Thursday. So it was eating up all of the capacity on their shared disk array and leaving nothing for them. But they were never seeing that, and that's what makes SAN purchase so much harder to get right, because you have to balance loads, and they may be different, completely different technical stacks, completely different people. So we want to make sure that we avoid those conflicts as much as possible. So human data entry, the thing about human data entry is you're going to get feedback on it. So when things don't work, people are going to tell you. The good news is it's very easy to test. It's easy to unit test, so you can have an understanding of what it will look like under no load. I'm running it on a system with no load in test, and I can see that. And that's really important to understand what the best you can do is. So if somebody complains to me and they say, hey, it takes me 10 seconds to enter an order, and I know the best it can ever do is 9 seconds, I'm not going to care about them. And I had a client that said, oh, it takes us 10 minutes to enter an order. And I said, that doesn't sound right. We went there, we looked at everything, and it turns out they dropped an index. They dropped an index on a polling table. That polling table was ripping through these polling records over and over and over again. It was eating up the whole system. And they were getting nothing done. So everybody was waiting on that polling system in the background, and they were seeing it on rote end user data entry processes. And it had nothing to do with the entry process itself. So we went out there, we put the index back in there, they fixed it, and they said, oh, it's great now, it runs really fast. They called me back like 3 months later and they said, oh, it's really slow. And I said, what do you mean? And I started to go into problem solve mode. And then I went, oh, before we go any further, how long does it take? Oh, it takes 11 seconds to enter an order. And I went, they were used to getting 10 seconds, so now that 11 seconds was unacceptable. So you have to look at when you're solving these problems as what the real problem is. So understanding in a unit test what's possible So understanding that there could be a little bit of overhead in multi-user mode. Machine data entry. This can have a significant impact on performance, but one of the things that's harder to do is really test it. I can unit test the actual insert process and I can get that information back. But generally there's a lot of steps in the process, okay? And so there might be a drop into one directory, then a move, and then something else. And all of those things have different effects on performance. So I need to make sure that I have proper timing of all the aspects of it, and when I do a test, it's an end-to-end test, not just a unit test. And then I have to figure out how it works. One of the things is these polling logistics are the ones that really, and I talked about that just in the last example, those polling type operations tend to get bogged down, and they look fine when you test them in test because you have 10 records. When you have 10 million records and you're scanning through all of those, it becomes worse and worse and worse. And generally, like if you look at any monitoring software, you can see how these time things, the time that it takes to complete these processes continually just moves up. And that way you know that's an index problem, because as you add rows, you're adding overhead and problems. So that's what we want to look for. One of the things we have is a hot block. And we've had this in a lot of cases where people are going out there and they're updating a control record. It's the last order number, it's the something else. And maybe they have 3 or 4 of them and they're all sitting in one block. And when you go out there and you look at the latches, you'll see a whole bunch of BF latches out there. And you'll see that, and it will never subside. It just runs and constantly have this contention. And we found out that, oh, okay, we'll just change that. Instead of doing a delete and create, it does a update in place. And that's the whole thing of it very, very quickly. We've also had places where we've said, okay, instead of having one of those, we have multiple of those. Or we use a sequence rather than using our own homegrown logic. So what we're trying to do is eliminate the latch contention that we see for those type of operations, and Progress gives us some tools, but we can also do things intelligently as we think about the application. Bulk data entry, this is the stuff that Baptiste was talking about. It really comes up in purges. A lot of people want to purge, but it's also if you're onboarding somebody new onto your application, you'll have a lot of data to bring on there. You do all this. And you want to make sure that 1, you're loading that data as efficiently as possible, and 2, you're reducing the load on other people using the application. And the data purges are very much more expensive than inserts. So deleting records costs more than inserting records. I know lots of people who have never actually done an archive and delete, and they have millions or billions of rows, and they keep doing this saying we can't afford to ever archive and delete. And the right way to do that is to archive and delete in pieces. You just do a little bit each of your dry spells and be able to take advantage of low tide on your system and be able to get work done. Backup and recovery. You do it every day. Hopefully, you do it every day. You're going to back up from one spot on disk, and that's going to use some of the cache. And it's going to go to another spot on disk, and that's going to use some of the cache. So it's a very intensive operation, and it tends to create issues. With a progress backup, you can reduce its impact by using BP, which is private buffers, and it'll tell it to use only those buffers and not infect the whole progress buffer pool. You can't do much about the disk cache, but you can do something about the progress buffer cache. So it's very important to use that. But Tom did a test, and we have a client that had local SSD storage. And yesterday, Baptiste was talking about the performance of his disk, of having high latency. His high latency was 3 milliseconds. Well, 3 milliseconds was better than any spinning disk could do just a few years ago. Now at SSD, we want to see latencies at a percentage of a second. You want to see point something milliseconds out there. So we're looking for very, very small. Yes, Jake? Yeah.
We had a comment from the chat here from Stefan Drissen saying that they were doing 120 gig backups in 8 hours because they were running with Windows Task Scheduler, which has that default low priority.
Yeah, he was talking about Windows Task Scheduler, and because the default priority on Windows tasks that are scheduled tasks is low priority, their backup on a very small database was taking 8 hours. And that's not uncommon, but it's just one of the many reasons that you probably don't want to run Windows to begin with. But if you have to, you can run and make sure that you don't allow it to devalue your process and cause that. And also that devalued can cause other issues as well out there, because you can have latches that are held for abnormally long periods of time, and that will impact users on the other side. But Tom did this test and he restored the backup, and it took 54 minutes to restore. He went over and used Azure, and he set up on a high performance dedicated system and all of that, and it took 11 hours. So this is something where this 54 minutes is not as, you'd like it to be less, but it's still acceptable for 2 terabytes. 11 hours is not acceptable for any business I know, so you can't run that way. So in this case, we know that Azure isn't really a solution for that. Yes?
That doesn't count the almost 24 hours that it took to transfer the backup from Linux to Azure.
Yeah, and Tom was saying that it didn't, this didn't count any of the transfer time of getting it there. But I'm assuming that if you've done a backup local to disk and you're restoring it local to disk, I'm giving it the benefit of the doubt and saying it only took 11 hours. It didn't take 35 hours. But the point is that when you go to cloud storage, cloud infrastructure, performance is going to be very hard to get. And it's going to be very hard to get. And we talked yesterday, I talked about the ephemeral storage on AWS, and it's very fast because, surprise, it's local. So it's in the box that you're on, and it's going to be very, very fast. So you can reduce times by doing things like that, but this is stuff that needs to be tested in advance. You don't want this to catch you when you need to use your backup, and that's what people usually find out, how long it takes to do a restore. Hardware. SSD, local SSD if possible. Network storage, we talked about how your response time grows as you increase the distance between the host and the storage. So we want to make sure that we keep the host and the storage as close together as we possibly can. CPUs, we talked about fewer, faster CPUs. Buying CPUs, I don't want to buy the 38-way at 2.5 gigahertz. I want to buy 8-way at 4 gigahertz, because there's still loads of things that are single-threaded inside the database manager, and the right operations really exercise those things that are more single-threaded, that have to have more control over. So it's important there. And I'll talk a little bit about virtualization again as well. Beware of tiered storage. Everybody just wants tier 1. So why buy tiered storage if you just want the top tier anyway? They keep trying to sell you these other disks that you don't want. So buy SSD storage. If you're going to buy a SAN that's all SSD throughout. If you're going to spend money, spend it all. So Aspirin Principle. If one works, 8 is going to be better? No. If one works, one works. So let's use that. Just buy the number of cores you need and try to stay away from shared infrastructure if you can. So if you can stay away from virtualization, because some people say, well, I bought the 38 cores because I'm going to virtualize and I'm going to have a whole bunch of different things out there. Well, you are, but you're going to have a whole bunch of slow things out there. your database is generally one of the prime movers in your infrastructure. It's probably the most intensive application you're going to have. And if you don't need virtualization features, then don't use virtualization. If you can run on bare metal, you're going to run as fast as you possibly can because you're eliminating another operating layer in there. So never ever overcommit resources. Memory or disk, you cannot overcommit resources. Virtualize only if you need to, so it's better to not virtualize. No thin provisioning of anything. You're going to end up having headaches that you're going to have to address later. The problem with all of this stuff for virtualization is you don't see it straight away. You see it as you add load.
Question from the chat, Adam, what about RAID nowadays?
Question about RAID. What about RAID nowadays? Well, I used to have this full stop, don't ever use RAID 5, you don't want to ever do that, but now I'm less militant about it because I can see there's a reason for it. But I do want to test the very intensive write operations and restore in the RAID environment to see how much it costs me. The problem is that I'm paying for something that I'm not necessarily going to take advantage of very often. Okay? I'm not going to have to restore my backup very often, I hope. And I'm paying for that. So there's a cost-benefit ratio there. For the vast majority of what you do, RAID 5 will probably work if it's SSD. If it's not SSD, and you start getting into RAID 6, which has two, all of that, I generally recommend against going that way. For me, if I were trying to build the fastest, I'd build RAID 10. If I was worried about the amount of money spent, I would test my intensive operations, and I would allow RAID 5 if they passed muster. Okay, so that's the long answer to a short question. So only count real cores. We don't count threads. Threads are not cores. And remember, this is one of the biggest things, is remember to save some resources for the replication host itself, or the virtualization host itself. Yes?
Sorry, another question from the chat. Is ephemeral storage a viable solution for production data? According to an article, the data is purged if the instance is stopped. That's from Garrett.
Okay, ephemeral storage, what it says is ephemeral storage is purged if the instance is purged, and that's true. But your storage in your computer room is also purged if you take your computer and throw it off the loading dock in the back. Okay? So the thing here is, if you don't do anything stupid, then ephemeral storage is fine. You can use it, it's durable, and it's going to give you excellent performance. So yes, you can use it for that. It's not going away. You have to defend yourself against stupid. And I mean, some people say there's no defense against stupid, but you have to understand that if you took your computer and threw it off the loading dock in the back of your building, you'd be doing the same thing as you are when you remove that. It seems a lot easier, but the analogy fits. Application advice. Bulk your updates, and we found out that doing these one by one is never a good idea. We want to go out there and get multiple things together because we get more throughput for that and it works better. But I'm also going to say keep your transaction and record scope small. Well, I just said two different things that I just wanted you to do. And it's a balance. You have to be able to balance the two. You have to use buffers as much as you can. You have to use pro data sets, you have to use temp tables and get that stuff in there to be able to do updates as efficiently as possible out there. You can use our tool or Promon to monitor and test your application. And it's really important to be able to run a unit test through there and figure out how many requests and how many updates you're doing. And it's really important to have, this comparison of exactly what you're doing and how it's working. So that's really important. Promon and Protop Free can both help you with that. And then the big thing is that we look at table access and index access a great deal when people call us up with performance problems, because there's generally something that's going to poke its head up very, very high for you. And it's going to make it really obvious as to what you need to address, because you're going to see this one table that's being accessed 40 or 50 times as much as every other table out there. And you'll find it, be able to knock that one down and then move to the next one. And use the statement cache as well to figure out where you are. You can turn it on dynamically now, so that's good. You have a way of doing this. We're looking for high table reads. We're looking for high index reads. Sometimes things won't show up as high table reads. They'll show up as high index reads instead. So you need to look at both. And then the rapid readers we talked about, that Tom has talked about in the past. These rapid readers are small tables that get rapidly accessed over and over and over again. It might be a product master table. It might be something. And don't think of them being very, very small. They don't have to be very small. They have to be fairly static, but they don't have to be small. You want to cache those into the alternate buffer pool and make sure that the alternate buffer pool is larger than enough space to hold all that. What you're eliminating is you're eliminating all of the latch traffic that deals with those tables, and it's significant. So if you can eliminate that on things that you're reading 1 billion times a day, that's a life by 1 billion pinpricks instead of death by 1 billion pinpricks if you can solve it. So those things, a lot of people think of small tables. I think of managed size tables, tables that I know how big they are, and I know that I can set a B2 large enough to do that.
Sorry,
no?
A little behind. Is there a sweet spot for update bulking? So 1,000 records is better than, say, 10,000 records?
Batiste, is there for update bulking or delete bulking, is there a sweet spot for it? And the answer is it's going to depend, and you're going to have to test it, but you know that the number is going to be in the thousands probably, and it's probably going to be higher than that. Is that a fair statement? Yeah? Ish? Fair-ish? Okay. So, but that's what you have to worry about, is that you don't want this to be a small number if you're going and doing the rote number of things over and over again. And it's just because if you do them in smaller chunks, you're going to get more of the external portions of the transaction that you have to deal with, and the external portions of the stuff that you have to deal with. That for transaction start and transaction stop, that'll increase the BI and the AI. It will also increase the number of latches that you have to get out in the database manager. So it will change a lot of stuff by going out there and creating bigger ones, because you'll have less transaction starts and ends out there. Okay, what we're trying to do is we're trying to move the stuff from the network to the disk. And what I want to do is I want to take things, and the best way to do that is with app server code. Because now I can ask a complex question to the app server, what's the average of this table? It can read every one of those things, but it does it locally. It only sends the answer back across the network to me. That saves me a huge amount of slow network performance. Again, what we're trying to do is we're trying to always push our bottleneck to the fastest resource. So going out there and using jumbo frames, so I'm sending less packets across the network, will help me. Having a large size will allow me to set that, to have less stuff or less packets go across there. From disk to memory, you want to have a big B where you're getting the highest achievable buffer hit rate you can get within reason. And you're trying to get high buffer hit rates, because the low buffer hit rates, even I think 98% is good, but 99% does 50% of the I/O. So that's a 1% change that made that, and it gets better up higher. B2, move your rapid readers, those things that are more isolated, over to B2. BP, do that for the backup. And then memory CPU, make sure you have a reasonable spin value. as Paul said, somewhere between 10 and 20,000 probably works for 99% of the people out there, and I tend to agree. That might be once in a row, Paul. Okay. Know what type of writing you're going to do. And the reason is because you need to be able to test for that. I need to test for bulk writes. I need to be able to test for that, and I need to be able to unit test for things that I do human entry. I need a unit test for that so I know what to expect. I need to end-to-end test things like EDI and other imports out there, and then figure the best way to service those needs, whether I need to put them to a different time of the day or whether I can do them some other way. Build fast, reliable hardware platform. And I used to always say fast, and it has to be fast and reliable. And you know, that was the question about the ephemeral storage. Is that reliable? Yes, it's reliable. It's fast and it's reliable. So local SSD, informed CPU usage. So stay away from NUMA, less CPUs, faster, and use your virtualization wisely, if at all. And then build and test all your application code, run it through ProTop, run it through the profiler, or use Promont, or write your own VST code to look at the stuff, so you can have an understanding of what that impact is, and you can see before it becomes a problem. And it's always better to catch it either in test or before it becomes a problem in production. Questions? Chat master? Comments? Personal problems? Refer those to Paul. Thank you very much. Oh, you have a personal problem?
Would you use BP on all clients, all jobs?
No, not really. I would use it on like the things that I'm gonna, if I'm gonna look at data that no one else is gonna traverse, okay? Then that's a wiser use of BP out there, because it's gonna say, okay, when I'm looking at all that old data, I'm not going to go and pollute any of the new data out there. So it's better to use it for those type of clients than it is to do it for something else.
And if you're doing that in application code, you can handle that within the code. You have a session handle.
Yeah, Tom's saying that there's a session handle that is in the ABL that allows you to dynamically set that BP. So if you had if you had one of those programs that was going out there and looking for historical invoices or something like that, you could dynamically set that in the code, run the code, and then dynamically set it back down to a lower value. Okay, thank you very much.